Hey guys, in this episode I'm going to introduce you to Http4k Connect, a new Kotlin-first SDK for AWS. Compared to the official offerings, it's lighter weight with stronger typing, zero reflection, and much more test friendly. Today I'm going to show it off to you using the DynamoDB SDK. Now let's get into it. First, let's add the DynamoDB library to the Gradle file, along with its fake, which we'll use for testing. Depending on where you get your AWS credentials, you may want the optional STS, instance metadata, and container credentials plugins as well. Now that everything's loaded, let's model something. If you know me, it should be no surprise I'm going with cats. So in the data class, there's no need for any fields to be mutable or to have default values like with the official SDKs, but you can still use them if you want. I'll also come up with a few samples. Meet my cats Kratos and Athena, and my friend's cat Titan. Now let's make a repository. We need to start with a DynamoDB client and a table name, which we can convert into a table mapper. Rather than annotate the model, the table definition is defined in the mapper itself. We need to pass in the model type and a hash key definition. There won't be any sort key for the primary index. Now let's come up with some simple repository actions to get, save, and delete items. I like to use operator functions for this. You can see that advanced operations like batch, get, and save are built right into the table mapper and handle any necessary chunking for you. Okay, so time for something a bit more advanced. Let's define a global secondary index on the birth date and ID. The schema is fully typed, so selecting it gives a fully type-safe API to work with. You can do simple operations like querying a partition key, and the mapper will handle any pagination for you. You can also override the query and filter conditions if you need more control. Finally, let's add a method to create the table. The mapper knows enough to create the primary index, but any secondary indexes need to be passed in. You won't use this in production, but it will be useful for the test harness later on. So now that we have a repository, let's get some test coverage. To build a test repository, just pass in a fake DynamoDB client and whatever table name we want. Since the repository is running against an in-memory DynamoDB server, you can create the table and it's ready instantly. Now, you can get started writing whatever tests you want. The fake table will take whatever you can throw at it, so go wild. Now run the tests, and look how fast they ran, under a second. Imagine how this can revolutionize your tests. No more fake implementations or sluggish Docker containers, just instant test coverage. So now, let's write a main function to use the repository for real. There's a bit more setup to get the right AWS credentials, region, and table name. So first, let's get the environment variables. With them, you can build the credentials chain. If you're on Lambda, you can get everything you need from the environment. If you're running locally, you'll probably have a few profiles to switch between from your credentials file. If you're on EC2 or ECS, you can get everything you need from their corresponding metadata services. So build your chain in order of priority. I recommend something like this. You'll also need a similar chain for the region. Once those are ready to go, just plug them into the DynamoDB clients. Load the table name from the environment, and you've got your real repository. You can build your application around it, or you can just do some silly stuff like this. But if you were to run the main function right now, you might get an error like this. That's because the table mapper has no idea how to map the data class without reflection. But why did it work in our tests? No idea. For some reason, Kotlin Reflects just gets bundled into the test class path, whether you want to or not. So let me know in the comments if you know why, because I don't. The simplest way to fix this is to just add Kotlin Reflect as the error suggests. This is a perfectly fine solution for most applications, but it won't fly for Lambda, where reflection is a surefire recipe for long cold starts. So let's learn how to do without it. There's two ways to do this. Write the JSON adapter by hand, or use a code generator to do it for you. I'm going to use the CodeSheet plugin for Moshi to generate the adapters for me. So to get it running, add KSP to the project, then get CodeSheet, and configure KSP to run it. Now mark the model and the JSON adapter for code generation. So now when you run the compiler, the adapter gets generated and it's ready to be used. So this part can be a little finicky. If your IDE can't find the class after it gets generated, just Try refreshing, recompiling, closing, and opening the IDE again. It'll get there. It's just a little finicky. So now when you run the compiler, the adapter gets generated and it's ready to be used. Unfortunately, you can't modify the table's original marshaller. So let's make a new one. Let's start a Moshi builder and add the generated adapter. But at this point, Moshi doesn't really know how to handle anything else. So Http4k can configure the rest for us. Now, convert the Moshi into an Http4k auto marshaller and plug it into the table. And that's it. Now the main function runs. So that was your introduction to Http4k Connect. I hope you'll give it a shot yourself and let me know in the comments if you like it. But in any case, I'll see you next time. Thanks for watching.